So this is the November 2012 paper of Mathematics B. It's the Statistics and Probability module, and it's the higher tier. It's also a calculator paper. Our first question is just a stem and leaf diagram. As you can see, there are 15 pieces of data, 15 baskets of strawberries, and they've also given us some room here to start with our unordered stem and leaf diagram. When we've done our unordered stem and leaf diagram, we can then put it into our ordered stem and leaf diagram, and including the key as well. So let's start with the unordered stem and leaf diagram. We draw it very, very similarly to the one below it. This is the reason that they have given us this extra space. Now, we can see with a close look to the data that our lowest number is 189. So that means on our stem, our first piece of stem, we can put 18. We can also see that our highest piece of data is 223. So on our biggest piece of stem, we can put in 22. And we can fill in each gap accordingly. Next thing we do is we go through each set of data and put it into our unordered stem and leaf diagram. So our first one is 193. That means we put 3 into the 19 and cross off. With our 200, we go to the 20 and put a 0 on the leaf side of it and cross it off as we go along. On our 207, we go to our 20 and put a 7 in the leaf side again. And we do this for all the sets of data. So let me carry on with this here. Now, we have everything in our unordered stem and leaf diagram, and now we have to put it into the ordered stem and leaf, and we have to put the numbers in order. So, move down to the next bit down here, and we have our printed out stem and leaf for us here. So we put the exact same stems in, 21 and 22, and then we just order each piece of data, starting from smallest going up to the largest. There's our ordered stem and leaf diagram. To get full marks in this question, we also have to include a key. I'm going to pick the 19 stem part. So we put in 19, and you can pick any of these numbers here, and we just say what it means. So 19 line 3 means 193. So the marking scheme for this question goes as follows. You'll get 2 marks for an ordered stem and leaf diagram, and you will get 1 mark for the key. Question 2 is a probability question. It tells us that there's a 4-sided spinner, and the sides of the spinner are labelled A, B, C, and D. We have a probability table that shows the probability that each letter will appear once it's spun. It tells us that Amber spins the spinner once, and they want us to work out the probability that the spinner will land on C. We don't have that. However, we do know that when we add up all of these probabilities, these 4 probabilities, that they will equal 1. So, what we do first is, we add up the probability of A, which is 0.12, plus B, which is 0.39, plus D, which is 0.18, and we know this to be 0.69. So we know that to get the probability of C, we just take away this number from 1. And because it's a calculator paper, we can put this sum into our calculator quite quickly, and we can see that the answer will be 0.31. The second part of this question, it tells us that Lucy's going to spin the spinner 50 times. And they want us to work out an estimate for the number of times the spinner will land on A. To get this question, what we have to do is multiply 0.12, which is the probability, of A appearing, and we multiply it by 50. This gives us an answer of 6. So we know our estimate will be 6. The marking scheme for this one is 2A, you will get 1 mark for this line here, and then you will get the second mark for this one for this line here. All in all, giving you 2 marks. Second part, you will get 1 mark if you show this part, and then you will get another mark for showing the answer, 6. For our third question, it tells us that Faisal weighs 50 pumpkins, and the information from this 50 pumpkins is in this frequency table. It also wants us to work out an estimate for the mean weight of all the pumpkins. Now, because it's an estimate, and we're working with group data, we only ever use the midpoints here. So, our midpoint for this section here, this class interval, is 2. Our midpoint for this class interval is 6. Our midpoint between 8 and 12 is 10. And our midpoint between 12 and 16 is 14. The next method that we use in this question is to multiply the midpoint by the frequency in each part. So what we do here is we multiply 2 by 11 and we get 22. We multiply 6 by 23 and we get 138. We multiply 10 by 14 and we get 140. And we multiply 14 by 2 and we get 28. Our next step is we add up all of these numbers. And this will give us an estimate for the total weight of all the 50 pumpkins. So because it's a calculator exam, we can just put this really quickly into our calculator and we get 328 kilograms. So that's an estimate for the total weight of all the pumpkins. Now, they also tell us that there are 50 pumpkins. To find the mean, we divide the total weight by the total number of pumpkins. That will give us the sum 328 divided by 50, and that equals 6.56 kg. So our answer is 6.56 kilograms. The marking scheme for this question is as follows. You will get 2 marks for using all the correct midpoints. Your third mark you will get for knowing that you divide the total weight by the number of pumpkins. And your fourth mark will be for a correct answer, giving you a total of 4 marks. The fourth question tells us that a survey was carried out for a magazine. There was 90 owners of cats were asked to write down the make of cat food that their cats liked best. And here's the representation of that survey here in our bar chart. It tells us that 10 people liked Kitty, 35 people said their cats liked Top Cat, 30 people said their cats liked Catkins, and 15 people said their cats liked Cool Cats. The next thing they tell us is they want us to represent this data in a pie chart. Now, with all pie charts, we have to find out how many degrees one owner represents. And the way we do this is we divide 360, because there are 360 degrees in a circle, and we divide this by 90 to see how many degrees one person gets. So 360 divided by 90 is 4, and that means that each cat owner gets 4 degrees and is represented by 4 degrees in our pie chart. So now we can work out how many degrees in our pie chart each brand of cat food will get. So like I said, there was 10 owners of cats who liked Kitty, so we multiply 10 by 4 and that will give us 40. As we can see, there are 35 owners who said Top Cat was their favorite. And we multiply 35 by 4 and we get 140 degrees. Catkins has 30 people who said their cats liked it best, and so we multiply 30 by 4 and we get 120 degrees. And finally, Cool Cat said 15 owners liked their cat food the best, so we multiply 15 by 4 and we get 60 degrees. Now, a quick way of checking to make sure that we are correct is making sure that these all add up to 360. And if we were to put these into a calculator, they would add up to 360 degrees. Our next step is to put all this information into our pie chart. So they've already told us, or they've already put the kitty representation in there. So this is 40 degrees. Now we just go down the line of our list of degrees and put them into our pie chart. So we know that we can start from here and we put a protractor in and we use it. And we mark 140 on our exam paper. Do not fall into the trap of saying that this is 140. Remember, 140 degrees is an obtuse angle, which means it'll be greater than 90 degrees, but smaller than 180 degrees. So, we can just mark in our next piece of data. And that is Top Cat. Our next piece of data is Catkins, and that's 120 degrees. Put our protractor in again, make sure it's lined up in the center, and we know it's going to be 120 degrees. Remember again, it's an obtuse angle, so it's going to be greater than my 90-degree line. So we're going to mark it here. That is our Catkins. And our next sector is Cool Cat. And our marking scheme on this particular question was you get 1 mark for being able to tell me that it's 4 degrees per cat owner. You get 1 mark for having any of these two correct. So any of these 2 degrees correct. And then you get full marks for having a completely correct pie chart. Question 5 shows us a scatter graph of marks given from 2 judges to children in a piano competition. Judge A's marks are along the bottom, along the x-axis, and Judge B's marks are along the y-axis. First question is, they ask us to describe the correlation. When we see that the marks going from bottom left up to top right, we know that this is a positive correlation. Now, the next part asks us to use a scatter graph to estimate Judge B's marks for this child based on Judge A giving 44 marks to another child. So the first thing we have to do is draw a line of best fit. Line of best fit should be a line straight through the middle of all the data on the scatter graph, trying to take in as many points as possible. Remember, you're drawing this by eye, so it's not going to be as precise as possible. So that there is our line of best fit. The next thing is we go back to the question and they ask us to use the scatter graph to estimate Judge B's mark for this child after they were given 44 marks by Judge A. So what we do is we go back to our scatter graph, we go to Judge A's marks and we find 44 on it. Now going by this, 44 will be here. So we draw a line directly up from there to our line of best fit. Then from where it meets the line of best fit, we draw a line across the Judge B's marks. And then we take our reading from that. And we can see that Judge B's marks would be about 48 to 50. So I'm going to put down 49 marks. And our answer is 49. The marking scheme for this question is quite a simple one. You'll get 1 mark for saying that it is a positive correlation. The second part, I put down 49, and you will get 1 mark for using your line of best fit, and you'll get another mark for giving a correct answer. Because I said the line of best fit is done by hand and it's not a precise measurement, they do give you a mark for any answer between 46 and 54 marks. Question 6 is as follows. They tell us that there are 200 students in the college, and each student studies one of art, graphics, and textiles. Straight away they do tell us that there are 116 female students, of which 26 study graphics. They also tell us that 22 males study textiles, and a total of 130 students study art. The final piece of information that they tell us is the number of students who study graphics is equal to the number of students who study textiles. And they want us to work out how many male students study art. First thing we do is we draw a two-way table to solve this question. Doesn't have to be a precise table, just enough to be able to put the information that we have into it. So now we have our table drawn, we can put it in. So our information goes in like this. We're going to put our females and males on the left hand side, and we're going to give ourselves a total row. And on our columns we're going to put in A for art, G for graphics, T for textiles, and we also give ourselves a total column. So let's go back to what it tells us exactly. It tells us that there is a total of 116 females. So we know that in this box we can put in 116. It also tells us that there are 26 females studying graphics. So in our graphics box, we can put in 26 females. It also tells us that 22 males study textiles. And then it also tells us that there is a total of 130 students studying art. This is the next piece of important information. They tell us that the number of students who study graphics is the same as the number of students who study textiles. Now they've told us that there are 130 students studying art, and then from that last piece of information we can tell that there are 70 students studying graphics and textiles. We get this number from taking 130 away from 200. Then they tell us that the number of students studying graphics is the same as the number of students studying textiles. So we can just halve this number here, 70. So we can halve 70 to give us 35. And we know that there are 35 students studying graphics and there are 35 students studying textiles. Now from this piece of information, we can start setting about completing our table. So we know that 130 plus 35 will give us 200. Because there are 200 students as given to us in the question. For this box here, we can take 116 away from 200, and that will give us 84. So we know that there are 84 males in the college. Our next piece of information is we can find out how many females study textiles. So to do that, we take away 22 from 35, and that will give us 13. So there are 13 females studying textiles. Next piece of information that we can do is to find how many males do graphics. To do this, we can take 26 away from 35, and that will leave us with 9. So there are 9 males studying graphics. Going back to the question then, it tells us that they want to work out how many male students study art in the college. So if we know there are 84 males in the college, and there are 9 plus 22 who do graphics and textiles, we know that the other males that are left over study art. So we can add 22 and 9 and then take away that number from 84 to give us the number of males studying art. And that leaves us with 53. So our answer is 53. The marking scheme for question 6 is as follows. You get 1 mark for being able to tell that there are 84 males involved in the college. You get 1 mark for being able to tell that there were 35 students who do graphics and textiles. You get 1 mark for being able to tell that there were 9 males who do graphics, and then your 4th and final mark is for a complete correct answer, giving you 53. So you get 4 marks for that question. Question 7 looks at fractions. It tells us that there are female and male students at a disco. One of these students is chosen at random. The probability that this student is male is 2/5. They also tell us that there are 96 females at the disco. They want you to tell us the total number of students at the disco. So first of all, they say that there are males and that they make up 2/5 of the population at the disco. That means that the females must make up 3/5 of the population. The next important piece of information is they tell us that there are 96 females at the disco. So we know that 3/5 of the population equals 96 students. So if we know that 3/5 equals 96 students, we also know that 1/5 equals 96 divided by 3. And that equals 32 students. So 1/5 equals 32, and they want to know the total number of students at the disco. So 5/5 equals 32 times 5, and that will equal 160. So our answer is there are 160 students at the disco. The marking scheme for this question is as follows. For being able to tell how many students were represented by 1/5, you get 1 mark. To be able to tell how many students were in 5/5, you get 1 mark. And then to get a completely right answer, you get 1 mark for your 160 students as well. Question 8 is one of those questions where you compare the price of 2 shops that involves also a percentage discount given at the end of the task as well. So basically what's going on here is Joan is planning a skiing holiday in Hinterglemm for herself and her 2 children. They're going skiing for 6 days. And the 2 tables show the cost of ski hire, boot hire, and buying lift passes in 2 shops in the destination. All prices are in euros. So, the question also tells us that Joan will use her own skis and her own boots over the 6 days. But for the 6 days, she will need to hire skis for both her children, boots for both of her children, and lift passes for herself and both of her children. The next piece of information they give us is they tell us that each shop gives a discount off the total cost. So shop A gives a 5% discount, shop B gives a 3% discount. Joan wants to hire everything from the same shop, so everything will be bought from the cheaper shop. We have to decide which shop is cheaper for Joan. So, this is one of these questions where we split our page into 2 halves. And using the information they give us in the question, we're going to answer this question. So, first thing they tell us is that they're going for 6 days. And we need to know the cost of 6 days of skis and boots for the children. So from our tables, we can see that shop A hires skis for children for 6 days for 78 euros. But because there are 2 children, we can times this by 2, and this will give us 156 euros. The children are also getting boot hire at £52 for the 6 days, But because there are 2 kids, we can multiply our 52 euros by 2, and that will come out at 104 euros. We can also put in a lift pass for the children for 6 days at 165 euros, and we can multiply this by 2 because there are 2 children as well, and that works out to be 330 euros. The total for kids over 6 days equals this plus this plus this added together, and that will give us 590 euros. The next thing we have to add to it is Joan's lift pass equals, from our table we can see that is 236 euros. Total bill for shop A equals this figure plus this figure, so it's 590 euros plus 236, and that equals 826 euros. Shop A also gave a discount of 5%. So to do this, we use our multipliers, and we multiply 826 by 0.95, because with a 5% discount, it's going to be 95% of the cost. And when we get this into a calculator, this comes out as 784 euros and 70 cents. Now we go to shop B. We do the exact same thing. So we do 6 days for skis, boots, and lift pass for the kids is as follows. From our table, we can see in shop B that ski hire for 6 days is £68. 68 euros. But because there are 2 kids, we can multiply this by 2. And that gives us 136 euros. From our table, we can then see that boot hire for children is 48 euros. And because there are 2, we multiply this by 2. And this gives us 96 euros. And then we go on to our lift pass in shop B for 6 days for 2 kids is 160 multiplied by 2 equals 320. Total for kids equals this plus this plus this, and that gives us 552 euros. We also put in Joan's lift pass at 242 euros. Our total bill with shop B equals 552 plus 242, and this equals 794 euros. And now we add on our 3% discount. Using our multiplier with a 3% discount, Joan would end up paying 97% of the bill, so this works out as 794 euros times 0.97, and that equals 770 euros and 18 cents. So we can see that shop B is cheaper, and to get full marks, we put down our answer as shop B is cheaper than shop A. The marking scheme for this question is you get 1 mark for one of these totals for the kids being right. You also get 1 mark for the total bill of each side. You get 1 mark for showing that you can use the multipliers. You also get 1 mark for getting the correct totals, including the discounts, and then you get your final full marks for deciding which is the cheaper shop. Question 9 is a straightforward question about questionnaires and whether or not samples are biased when they're asking questions from people. Nathan is doing a survey about DVDs and he writes a questionnaire. Nathan decides to hand out his questionnaire to women who are inside a DVD store. His sample is biased. Give 2 reasons why you think this is. So, the first one, he only asked females. And the second one would be, he must ask people in a different location as people in a DVD store would have a biased opinion. The second part of this question, part B, is asking you to find 2 things that are wrong with the questions on Nathan's questionnaires. His question goes, how many DVDs do you have? His first option is 0 to 5, his second option is 5 to 10, his third option is 11 to 15, and his fourth option is 16 to 20. The examiner would like you to tell him 2 things that are wrong with this question. The first thing that's wrong with it are that the first 2 boxes have overlapping values. What box would I tick if I had 5 DVDs? The second error with this question is, it is not an exhaustive list of options. Is not exhaustive. Again, what box would I tick if I had more than 20 DVDs? Marking scheme is quite straightforward for this question. You get 1 mark for each answer that you give. And there's a total of 4 marks for this. Question 10 is testing your ability to use algebraic expressions. So, they tell us that there are 5 female giraffes and they have a mean weight of X kg. They also tell us that there are 7 male giraffes and they have a mean weight of Y kg. They want us to write an expression in terms of X and Y for the mean weight of all 12 giraffes. So the first thing you would do is give an expression for the total weight. And that is 5x plus 7y. Now, to finish the question off, they want us to find out the mean weight of all 12 giraffes. Now, we know that the mean equals total weight all over total number of giraffes. So going from this, we know what our total weight is, and we know how many giraffes there are. So we can say that the mean equals 5x plus 7y divided by 12. And that is our answer. Marking scheme for this is quite simple. You get 1 mark for being able to show 5x or 7y, and then you get 1 mark, giving you a total of 2 marks for your total answer. Question 11 deals with compound interest. It tells us that Joseph invests £1,700 for 2 years at 4% per annum of compound interest. They want you to work out the value of his investment at the end of 2 years. Now we know that compound interest, you work out the interest for the first period, add it to the total, and then calculate the interest for the next period. So, let's do this for the first year. So, using our multiplier and the £1,700 initial investment, we can multiply this by our new multiplier, which is 1.04. And this is adding 4% to it. Using our calculator, we know that this is 1,700 £368 equals the investment after 1 year. Because it's compound interest, we then take the £1,768 and we reinvest it. So all we're doing is putting it back into the original sum. And we multiply the 1,768 by 1.04. And that gives us a total of £1,838 and 72p. So our full answer is £1,838 and 72p. Our marking scheme for this question is you get 1 mark for this part here and getting a correct answer. You get 1 mark for this part here, and then you get another mark for giving the correct answer. Question 12 shows us the graphs of 6 straight lines, and they want us to match each line with its corresponding equation at the bottom of the page. First thing we should do here is identify the gradient, the nature of each gradient of each graph, along with the y-intercept of each graph also. So we can see that on graph A, the gradient is a negative gradient because it's going down. And our y-intercept is 2, because that is where it cuts the y-axis. Graph B, our gradient is a positive gradient, as you can see, because it is going up, and our y-intercept is also 2. Graph C, we can see that the gradient is a negative gradient, and our y-intercept is negative 2. Graph D, excuse me, graph D's gradient is also a negative gradient, and our y-intercept is also negative 2. Graph E, our gradient is a positive gradient, and our y-intercept is 2. Graph F, our gradient is also positive, and our y-intercept is negative 2 also. Question 13 takes on the topic of stratified sampling. It shows us that there are 244 pupils in Year 9, 315 pupils in Year 10, 181 pupils in Year 11, giving us a total of 740 pupils altogether. Priya is going to do a survey of 70 students in the school, and she's going to use a sample stratified by year group. We have to work out the number of Year 9, Year 10 and Year 11 students that Priya should have in her sample. So first thing we do is we take our number of Year 9s, which is 244, and we place it over 740, which is our total. We multiply this by 60 because that is the number we're working with in the stratified sample. Putting this sum into our calculator, it comes out as 19.78. Again, we do the same for our Year 10. We put 315 over 740, multiply it by 60 because that is the number again that we're working with, and that gives us a number of 25.54. Finally, we take our Year 11 students and we take 181 of them and put it over 740 and multiply it by 60 again. This gives us a number of 14.68 pupils. Now, we want to get 60 pupils for our stratified sample. We have 19.78 for our Year 9s, we have 25.54, and we have 14.68 for our Year 11s. And we need to come up with a number that add up to, 3 numbers that add up to 60 based on these numbers. So, straight away we know that 19.78 pupils is not possible, so we round up to 20. Now, because this is 25.54 and this is 14.68, we will round down the number that has the lowest decimal number in it, and that is the 25.54, so we keep it at 25. And our last number, we round up to 15 based on our 14.68. Our next part in that question is, we have to explain what is meant by a random sample. A random sample is where all students must have an even chance of being chosen. And then they ask us to describe how Priya could take a random sample. Priya could put all the names in a hat and pull out 20 names from year 9, 25 names from year 10, and 15 names from year 11. The marking scheme from this question is as follows. You get 1 mark for one of these questions, these sums here. You get 1 mark for giving out these numbers here, and you get 1 mark for getting these correct as well. Second part of the question, you get 1 mark for an appropriate explanation of what a random sample is, and you get 2 marks, my apologies, you get 1 mark for a reasonable description of a random sample as well. Altogether, 5 marks. So question 16 starts off by telling us that there are 4 pens that are red in a box and 6 pens that are black in a box. Then it tells us that Josh takes at random a pen from the box. It says that he does not replace it by putting the pen into his bag. He then takes at random another pen from the box. They want us to work out the probability that Josh takes 1 pen of each colour. So the first thing we do is draw ourselves a probability tree. So we know that there's going to be 4 in 10 chances of him taking a red out on the first draw, and 6 out of 10 chances of him taking a black pen on the first draw. The next part of our probability tree is going to be the second choosing. And again, we mark it with a red and black on each part of the tree. So then, when we take out 1 red pen, and we don't replace it, that means that there are 3 out of 9 pens left, red pens left, and 6 out of 9 black pens left. But if he was to take out a black pen first, he'd have, with 6 out of 10, he would still have 4 pens out of 9 left, and he would also have 5 pens out of 9. So now we can find out the probability that Josh takes 1 of each colour out, based on our values here, 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 and here. So the first thing we do is probability of taking a red and a black pen out from the first part of the probability tree will be 4 out of 10 and 6 out of 9. So we multiply it when it's and. Or we could choose a black pen first, which will be 6 out of 10, and we could choose a red pen, which will be 4 out of 9. We multiply these across then. It's going to be 24 over 90 plus 24 over 90. This equals 48 over 90. Now we can put this down into its simplest form, and we can divide across by 2 on each case. So that will give us 24 on top and 45 on the bottom. This is not the simplest form of it, and we can simplify it again and divide both sides, top and bottom, by 3. And that would leave us with 8 over 15. So our answer is 8 over 15. So the marking scheme for this question will be 1 mark for showing the probability tree with all our fractions here. You will get another mark for these 2 sums here. You will get another mark for this sum here, the 24 over 90 plus 24 over 90, and your final mark will be for your answer of 8 over 15. Question 14 gives us a cumulative frequency graph displaying the results from a maths test given by Mrs. Angus in her maths class. First question they want us to do is use the cumulative frequency graph to find the median. The way we find the median is we look at how many people there are in the sample first. And we can see from here that there are 19 students. Now, in this case, n equals 19. The formula for finding the median piece of data is n plus 1 divided by 2. In that case, we can put 19 in plus 1 divided by 2 equals 20 over 2 equals 10. We're looking for the 10th piece of data on this cumulative frequency curve. Next thing we do is we go and we find the 10th piece of data and the mark that it corresponds to. We do this by drawing a line out from 10 to our graph. And from that point, we draw down to our x-axis. And from there, we can see that the median mark is 46. So the answer to this question is 46. So for question 14a, part 2, they're looking for us to find the interquartile range. The way we find the interquartile range is to subtract the lower quartile from the upper quartile. So our formula looks a little something like this. And to do this, we need to go back and use our cumulative frequency graph. From this, we can see that our upper quartile is the 15th piece of data. So we draw a line out from 15 to the curve, and we find its corresponding match on the x-axis. So we can see that it is 56. So our upper quartile range is 56 marks. Next we find our lower quartile. Going back to our graph again, we go to 5, which is our lower quartile piece of data, the 5th piece of data. We'll draw a line out again and find its corresponding mark on the x-axis. And in this case, it comes out at 30. So we know that our lower quartile equals 30 marks. Now we take this formula and we find out our interquartile range. So our upper quartile value is 56, and we subtract our lower quartile value, which is 30 marks. And that works out to be 26 marks. So our answer for this is the interquartile range is 26 marks. Question 14b wants us to interpret the marks from a box plot shown here. The marks show the results of a group of kids taking a maths test in Mr. Wilson's class. And they want us to compare the interquartile ranges of Mr. Wilson's with the interquartile range of Mrs. Angus. Now we've already found Mrs. Angus's interquartile range, and that is 26 marks. The next interquartile range we need to find is Mr. Wilson's, and that is represented here. The way we find it again is exactly the same as we did before. We subtract the lower quartile from the upper quartile. The upper quartile is found here, and it's found to be 64 marks. And the lower quartile is found here, and is found to be 28 marks. So using this formula here, we take 28 from 64, and that gives us our interquartile range for this piece of data. And the answer is, of course, 26. So that's our first part there. But they also want us to compare it. So we can say, to get the full marks, we can say the interquartile range of Mr. Wilson's class is higher than the interquartile range of Mrs. Angus' class. The marking scheme for question 14 is you get 1 mark for 46, but they will also accept 45, but they must also see the line drawn from 10. For the second part of part A, they will give you a mark for drawing your lines, seeing your lines there, and the last mark will be for this sum here and an answer. The second part, they will give you 1 mark for reading this box plot here and getting this sum and answer of 26, and then they will give you a final mark, for giving a comparison between the two interquartile ranges. Question 15 is a question about histograms. Here we have a frequency table showing how late flights were depending on how many hours they were late. We can see that there was a delay of between 0 and 2 for 4 flights, between 2 hours and 7 hours for 60 flights, between 7 hours and 11 hours for 40 flights, and between 11 hours and 13 hours for 6 flights. So the first thing we do to tackle this question is we try and find the frequency density. So we draw an extension onto this part of our table, and this will help us work out our frequency density. Now, to find the frequency density, our formula for finding the frequency density is frequency divided by class width. And our class width for this one is 2. Our class width for this part here is 5. Our class width for here is 4. And our class width for the final one is 2. To find the frequency density, we put the frequency over the class width. So for the first one, our frequency density is 2. For the second one, our frequency density is 60 divided by 5, it's 12. Our frequency density for the third interval is 40 divided by 4, which is 10. And finally, our frequency density for the fourth interval is 6 divided by 2 equals 3. So based on these numbers, we can work out our scale along the side on the x-axis. So we can put in our x-axis, our y-axis here, And for this part of the exercise, I'm going to go up in 2s. So, for delays of between 0 and 2 hours, we have a frequency density of 2. So between 0 and 2, we draw our line up as far as 2. For our next frequency density, which is 12, it is also between 2 and 7 hours. So between 2 and 7 hours, we go up as far as 12. For our third frequency density, it's 10, and it's between 7 hours and 11 hours. So between 7 hours and 11 hours, we go up as far as 10. And for our final one, between 11 and 13 hours, we go up as far as 3, which is approximately halfway into this box here. And that's our histogram drawn. Question 15b is another histogram question, but this time they've given us the histogram to work off. They want us to compare the number of flights that were late greater than 7 hours on Tuesday as opposed to the number of flights that were delayed by greater than 7 hours on Monday. We've already seen the Monday histogram in the previous question. It's the one that we've just completed. And we can see from our table that there were 46 flights that were later than 7 hours on Monday. So let's put that information down to one side so we can work with it later on. So on Monday, there were 46 flights that arrived later than 7 hours. So the next piece of information they tell us is that there were 12 flights that were delayed for up to 2 hours on Tuesday. And that's this box here, 12 hours. Now, the next thing I would do here is I would use our formula triangle, which helps us decide what we're going to do next. So basically this tells us that the formula can be gotten by multiplying the frequency density by the class width. Likewise, we can find the frequency density by dividing the frequency by the class width, and also finding the class width by dividing the frequency by the frequency density. In this case, we need to find the frequency density. That is the y-axis measurement here. So we know that the frequency is 12 and our class interval is 2. So we can divide 12 by 2. This gives us 6. So we know that our frequency density along here is 6. This is 6 here. So this helps us decide our scale. And it's clearly going down in 2s and up again in 2s as well. So working with this then, we also want to find out what the frequency of this box is. So we want to know how many flights this represents in here that were late greater than 7 hours. And the way we do that is, we want to find the frequency. So we multiply the frequency density, which is this measurement here, which is 7, by the class width, which is 1, 2, 3, 4, 5, 6, 7. So we multiply the frequency density, which is 7, by the class width, which is 7 also. That gives us an answer of 49. And going back to the original question, Avi said that there were more flights late greater than 7 hours on Monday than there were on Tuesday. And this is clearly false, because there were 49 on Tuesday, 46 on Monday. So clearly, Avi was incorrect. There were 3 flights more on Tuesday that were late by more than 7 hours. The marking scheme for this question is as follows. You get 2 marks for having all 4 bars correct, and then you get a 3rd mark for putting a correct scale on the x-axis. For the second part of question B, for the second part of question 15, you get 1 mark for figuring out the frequency, which is 49 for Tuesday, and then you also get 1 mark for saying that Avi was incorrect with a legitimate reason. For question 12, we were given 6 straight lines on 6 different graphs, as you can see them here. And we're also given 6 equations of 6 lines that we have to match up with all of the graphs. The first thing we have to do with this question is realize that we have to know 3 pieces of information. The first thing we have to know is the difference between a positive and negative gradient of a line. So if the graph is going like that, in that direction, we know it'll be a positive gradient. If the line is going like that, we know it'll be a negative gradient. The next thing we have to learn how to do, and we must know going into the exam, is how to find the gradient of a line. So our formula for the gradient is difference in the y-coordinates divided by the difference in the x-coordinates. And then the final piece of information that we need to know is the equation of a line, the format it takes. So the format for when we want to find out what the gradient and the y-intercept is y equals mx plus c, where m equals the gradient and c equals the y-intercept. So, looking at our first graph, we have to find the gradient. We must find the gradient and the y-intercept of each line. So, starting with graph A, we can see that graph A, the gradient of graph A it's a negative gradient, and we have 2 over 4 equals minus a half. And our y-intercept equals 2 as well. On graph B, we know that the gradient will be a positive gradient, and it'll be 2 over 4 equals a half. And our y-intercept for this particular graph is 2. Graph C, our gradient is a negative gradient, and we have our 2 over 1, and that is minus 2. Our y-intercept will be negative 2. Our gradient on graph D is a negative gradient with our 2 over 4, and that is minus a half. Our y-intercept equals minus 2. Graph E, our gradient equals a positive gradient with 2 divided by 1 equals 2. And our y-intercept equals 2. On graph F, our gradient, again, is a positive gradient, and it's 2 over 1. And that's a 2 gradient. And our y-intercept is minus 2. Now, all of this information that we've just got from these 6 graphs, we can apply to the 6 equations of a line below. And using our generic equation of a line, y equals mx plus c, where m equals the gradient and c equals y-intercept, we can use this information here. So we can see in equation 1 that the gradient is a half and the y-intercept is a 2. So we're looking for one of the graphs up here with a gradient of positive a half and a y-intercept of 2. And if you go to graph B, we can see that it is a positive half and a y-intercept of 2. So our first one is B. The next one, we're looking for a line that has a gradient of 2 and a y-intercept of minus 2. So we're looking for a gradient of 2 and a y-intercept of minus 2. And if we go to graph F, we can see that it has a gradient of 2 and a y-intercept of minus 2. The next one, we can see it has a gradient of minus a half and a y-intercept of positive 2. So if we look through our graphs up here, we can see that graph A has a gradient of minus a half and a y-intercept of 2. So we know that our third one is A. Looking at the fourth equation, we can see that the gradient will be negative 2 and the y-intercept will be negative 2 also. So we're looking for a line that has negative 2 gradient and intercepts the y-axis at negative 2 as well. So if we look up here, we can see that graph C has a gradient of minus 2 and intercepts the y-axis at minus 2 also. So our answer to the fourth one will be C. And you can do this for the last two as well. All you're doing is matching up the gradients and the y-intercepts. So my last two will go as follows. It'll be E and D. The marking scheme for this question is you get 3 marks for all 6 correct. You get 2 marks for 4 or 5 correct. And you get 1 mark for 2 or 3 correct.